Good day, everybody. I hope everyone had an absolute wonderful long weekend and Easter weekend. But now we're back at it, starting a new chapter. I just want to make a note that I believe I'm still going through all the assignments, and I'm pretty sure about 80% of you guys have handed them in. That leaves about 20% who haven't. If you haven't spoken to me already, then unfortunately your mark is going to be a 0 for that assignment. And yes, it does go towards your final mark. Some people had to hand them in late because they weren't sure on how to submit files through the e-learning. So a few people got extensions, so I guess that's why I gave the extra day. I was supposed to be doing the Friday, but I gave it to Saturday just for you guys to figure out how to submit the files or figure out the e-learning. So in the future, there will be one at the end of every chapter. So please be prepared for those assignments, and please have them completed on time. Okay, moving on to chapter 7. The next two chapters are the most important chapters of the course, not only for this year, but for all the upcoming years. So there's a lot of key information that I'll be giving to you in the next two chapters that you will need for grade 10 and 11 and grade 12. Okay, chapter 5 is not that difficult. It is a little bit challenging, but then chapter 6 is definitely the most challenging chapter for the course. So it's going to start off a little bit easy, this one. Get a little bit confusing when it gets to the middle, but if you ever have any questions, you can always email me. All right, here we go. So direct variation. Okay, so we're learning direct variation today, and then tomorrow we'll be doing partial variation. So direct variation is a relationship between two variables in which one variable is a constant multiple of the other. Okay, so when we're talking about variables, we learned two of them already in their graphing unit, which is the x and y. So our standard one will be x and y. But they could be anything. We did last chapter, we did distance versus time, so that would d and t. It could be like kilometers per hour, so kilometer distance versus it's distance time again. So there's different ones, variables. Okay, but these ones, oh my goodness, the spelling mistakes. So it's a constant multiple of the other. Okay, so one's a multiple of the other. We'll get to the examples. The graph for direct variation always starts at 0. Okay, so if it's just a regular one quadrant graph, it will start at 0. But if it becomes into a Cartesian plane, which we haven't really touched on yet, it will go through 0, 0. So an example here, I have a graph, it starts at 0, 0, and it has to go upwards to the right. It has to. You can't go down from here. So it's always up towards the right. So this is direct variation, and this would be your x variable and your y variable. Okay, if in the future we'll get to ones where we have a Cartesian plane, but the line will still go through, start at 0, 0, but could go both ways. Okay, so the line will be continuous, but this is not this chapter. This will be more for the next chapter. Okay, so direct variation starts at 0. So 0 and 0. Okay, it's always going to be linear. Okay, always a linear relation. Okay, and then our equation is y equals mx. Okay, so y is the dependent variable. Let's see if I can get this a little closer. Hopefully it's not too blurry. So y is the dependent variable. Remember, it depends upon the independent variable, which is our x, independent variable. This is getting clouder. Okay, and then our m is our constant multiple, or so the constant multiple okay, which is what we had here. So constant multiple is your m. This is also called the constant of variation. Constant of variation. Okay, so m is the constant multiple or the constant of variation. And this is what the graph is changing by. So what it's going up by. It could be going down. When we get to tomorrow, it could be going down. But right now it's just going up. So what the graph is changing by. Okay, so our direct variation is y equals mx. So y is your dependent, your x is your independent variable. So this is usually your y and your x. Okay, but in what we learned on distance time, this is the distance, this is the time. So m is our constant multiple, or called the constant of variation, and it's what the graph is changing by. Okay, so then example, let's put the example over here. So the example would be, so something simple, if you had a job, you would be getting paid, say, $13 every hour. So P equals 13H. Okay, so H is the hours. So that's your independent variable because the hours you work will affect your pay. So your pay will be based on how much you work. So this is just an example. So you get paid $13 for every hour that you work. So 13 is the constant of variation because that's what your pay would go up by. So if you work 1 hour, you get paid 13. If you work 2 hours, then you get another 13, which is 26. You work 3 hours, you get another 13, which is 39. So you constant of variation, or what your graph will be changing by, is 13. And your independent variable is your hours, because your hours affect how much you get paid, which is your dependent variable. Okay, and here our m, sorry, I'm just going to change over here. So just a side note, so our m, or constant of variation, is your dependent variable divided by your independent variable. So your dependent variable divided by your independent. Okay. Anything else I want to put there? Oh, yes, key note here. I'm just going to put this up here. In the textbook, they write it as y equals km. Okay? It's the same thing. So y equals mx is the same as y equals km. Okay? I don't know why the textbooks that uses k here. Sorry, not km. Kx. So the textbook uses y equals kx, but then later they change it the k to an m. Okay, so we're not going to use the k. Okay, we're just using m. Okay, so slope. So y equals mx, not y equals kx. Okay, just a note for that. All right, so let's go to our first question. Yvonne grew 33 centimeters in the last 3 years. What is the constant of variation? Okay, so our constant of variation, oh, did I say this was slope before? Ignore the word slope I said. So the constant of variation. Our constant of variation is m. Okay, right, and then write an equation. So we want to find what the constant of variation is how much is he going up by each year? Okay, so what is he changing by? So it's your dependent variable divided by your independent variable. Okay, so which affects the other? Does your height affect your age, or does your age affect your height? Your age will affect your height because the older you are, the more you grow, or the taller you get. So your height is dependent upon your age. So dependent is 33 and our independent is 3. So 33 divided by 3 is 11 centimeters per year. Okay, so that would be the constant of variation because his height is changing by 11 centimeters each year. Okay, so that's how you calculate the constant of variation, because I believe the textbook, the first question or two, is finding this constant variation. Again, they call it K in the textbook, but it should be M. Okay, so you're just dividing. That's all you're doing. And now we're going to write an equation. Okay, so it's just y equals 11x. Okay, so y and x are your standard variables, and in this case we're going up by 11, so his height is changing by 11 centimeters every year. Since it's a real life question, we can make the equation a bit better. So we could say his height grows by 11 per year. So you could put y, or let's do for age. So h, his height equals 11 times the age. No, let's put that back. Let's put y. So his height is going up by 11 centimeters per year. Okay, that was the part 2 of it. Write the equation. Okay, number 2. Naz works at H&M and earns $14 an hour. Make an equation. Okay, so the very basic one would be y equals 14x. Okay, so y and x, you're just plugging in how much it went up by, 14. But since it's a real life question, we want to get real variables. So E earns, so E equals $14 per hour. So 14H is our equation. Oh, draw a graph. I'm gonna get my pencil, my ruler. Okay, we're gonna be drawing a graph now. And this is very simple to draw a graph. Let's go, we're gonna go, I'm just looking ahead, it says 7 hours, so you wanna do one for 7 hours. So there's my graph. One, 2, 3, 4, 5, 6, 7. So 1 hour, 2 hours, 3 hours, 4, 5, 6, 7. And then this is very easy. You know it's going to go up by $14, so just make your scale at 14. So it goes 0, 14, 28, 42, 56, 70, 84, and 98. I think that's right. Okay, so we have to start. Remember, this is direct variation, so it has to start at 0. And that makes sense because if Naz doesn't work any hours, then she doesn't get any money. So for 0 hours, she makes $0. If she works 1 hour, then she'll get $14. If she works 2 hours, 28. If she works 3, 42. And then it would continue from there. So right now I'm just going to draw a line of best fit, going through the points with our arrow at the end. I did forget a couple of things here on my graph. Arrows, X and Y. This would be hours. This would be pay. Okay, evenly spaced. Evenly spaced, going up in equal increments. And then you can put title, Naz's pay. Okay, so that's the graph there. And it says for B, how much will she work for 7 hours, or how much does she earn if she works 7 hours? So there's two ways to do this one. One is to go by from the graph. So what we learned in chapter 2 is to do interpolation or extrapolation. So we go from 7 all the way up to our line, and it should have been here. Okay, so we should have that graph there. Okay, it should have been 98. So if you did interpolation and your graph was off a bit, then it'd be a different answer. But what we could do is we could use the equation. So E equals 14 and 7 is the hour. So we plug 7 into H. So 14 times 7. 7 times 4 is 8. Add the 2, $98. Okay, so $98 she would earn or make if she worked 7 hours. Okay, and that is the lesson today. Homework is at the bottom here, so page 242, 1 to 6, 8, and 14. Okay, I hope everybody is well, and if you have any questions, feel free to contact me. Have a wonderful week, and I'll be posting the next lesson on Thursday, so just 2 lessons this week. Okay, talk to you guys later. Bye.